Sorry, Braxton. No, I'm not. So yeah, I hope that you all watch the video. I hope that someone asked, should I take notes? And no, you don't have to. You can take notes today, but I hope you gained an understanding, even if it's a cursory sort of thin layer of understanding as to what the quadratic formula is. So anyways, today, this will be your last math lesson for me this year. It's the 14th. And this is in capital letters. It is a proper noun. It is not just some formula. It is the quadratic formula. What's it used for?
Oh, answering quadratic.
It is used to solve quadratic equations, right? And you might say to yourself, I thought that's what, like, I just got a quiz on, right? And that's one way to solve quadratic equations, by factoring. But the question becomes, like, what happens when I'm up against a quadratic equation when I look at it and I can't factor it? Therein lies the need for something else. And in Algebra 2, if you want, I can show you where this insane looking formula comes from. It actually is, it's not outside the realm of reality for a high school student, but we do have to learn completing the square. So that would be a September, October sort of Algebra 2 lesson. But if you're ever interested to know where this thing that I'm about to write up here comes from, I can show you. It wasn't invented, it's a naturally occurring sort of situational formula that makes perfect sense once you see it. But anyone know what it is by chance, the formula? I get the easy part. X equals there. Close. You're all forgetting one little thing. Ooh, negative b. Good job, right? Plus or minus of b squared minus. Good. And honestly, yeah, and good job. I can tell you watched the video because, I mean, and that's, I think, again, even if you didn't really like learn fully like how to do it, I think just having that first, even if it's a very half-hearted coat of paint, a first coat of paint makes a big difference on the second coat of paint, right? So just the fact that you're kind of aware that that is there, and you guys, that was pretty okay. You pieced it together okay. Anyways, it's the opposite of b, plus or minus a big long square root sign, then all divided by 2a. And again, it really, the first time you ever see where it comes from, it's kind of like, wow, pretty neat. But for today and tomorrow and the next day, and our usage of it for the rest of this year, we're not going to talk about where it came from. We're just going to use it. So like any formula, it has variables that need input. So if Hagen's about to use this formula, he's like, well, I can't use it until you tell me what numbers to put in. That's how formulas work. And that'll be like in geometry next year. Geometry's got a lot of like area, volume sort of formulas. So you got to tell me, like, what do I put in? And so our first math problem today is going to be x squared plus 3x minus 11 equals 0. And, I'll pop in and periodically just remind you of this throughout the lesson. But the reason today we have to bust out a much larger weapon is because if I gave this to you on yesterday's quiz, you could not do it. I mean, no offense, but it cannot be factored, you would agree. You understand factoring, obviously, as a class well enough to see right away that you're not going to find numbers that multiply to make negative 11 and that to make 3. It ain't happening, right? Hence the need for something bigger. So can you tell me from looking at my quadratic equation what A, B, and C are? A is not x squared. It is not just x. It is 1. Very good. A, B, and C are not variable values. They are the numbers that sit in front of the terms. And so you can't see it, but right there in front of x squared, you know, is the number 1, right? So the first thing I do when I get started on a quadratic formula is I write down a equals whatever it is. And then I put a little comma, and right next to it, what's b? B is 3. And what is c? Negative 11. And again, I'll change these. I'll write these in yellow so you can really see them. But A is right there, that yellow one. B is this positive 3 right here. And C is this negative 11 right here. So step 1 is to be able to identify your cast of characters, A, B, C. Now this next step, you have to do a little bit of math, but not a ton. You'll find this, I think, if you were confused by the video, that's perfectly normal. But I think you're gonna find as we do this, this is not bad, right? As with a lot of things, as long as you're just careful, you know, if you don't say something stupid like 3 squared is 6, or forget to change a minus and a negative when they're touching butts into a plus. Little fundamentally sort of things, if you can dodge those, this is not bad at all. So people think like, oh my God, that looks so hard. It's not at all. It's intimidating looking, but nah. So we begin. We're trying to figure out what the solutions to this equation are, and we certainly couldn't factor it, so we're going to plug it in and just go full bore into that big purple formula. So we write x equals, and we're off and running. What's the first thing we're going to put? Negative 3, right? And it does, the formula, the song does start out with like the quadratic formulas, negative b. So we say negative b, but in reality, the fact of the matter is we're just doing the opposite of b. So don't always think that what you put there is going to be a negative, right? Because if b's already a negative, then you're going to switch it back. So like in this case, we are though going to take the opposite of positive 3. So we're going to begin with a negative 3, and then that is a plus or minus sign. And then I like to make a big, long square root sign. I like to make sure I have plenty of room to do a little bit of math. At this step, I would encourage you not to write b squared, but rather write the answer to what it is. What is b squared? It is 9. And again, it's easy to say 6. And those are the little things that'll just be constant speed bumps in the road to your success. So try to, I mean, we're all human, but try to avoid the little knucklehead things. Now, the next thing I'm going to do is I'm going to copy down the minus sign. And then I'm going to put a 4. And the way I always like to do the quadratic formula is before I finish, I like to put 2 blank spaces next to the 4. And I skip it. Yeah, you guys heard me say that in the video, right? I skip it and I come back to it. I think the reason I figured out years ago to do that is that it's nice to take a little step away break so that you don't accidentally put the wrong numbers in there. So just take a little pause from the square root. Let's head to the bottom. And again, let's not write actually 2a. Let's just figure out what it equals. What's 2 times a? 2 in this case. 2 times 1 is 2. Now I like to go and I like to backfill. I go back to those 2 spaces, and what numbers are going to go into those spaces? Good job. So 1 goes where the a used to be, and negative 11 goes where the c used to be. Now, about exactly 50% of the time, what's about to happen will happen in the quadratic formula. And did anyone catch this from the video? We're not quite to the Dorito yet. Half the time, this number that I'm pointing to right here is going to be a negative. And that's important because there's this, I'm going to make it like green. There's this, like, you see this bubble cloud here? That's a multiplication problem with 3 numbers. How many negatives do you see in that bubble? Yeah. There's 2. There's the one that was on the negative 4, right? The minus 4 is like a negative 4. And then eventually it heads down the line and it collides with a negative 11. And what happens in math when 2 negatives multiply together? It turns to plus, right? Positive or plus. And so in the side, the square root, I'm actually turning this from a subtraction problem into an addition problem. And what it really now says inside is, so we got the square root sign, but what it really says inside is 9 plus 44. Do you see it? I just power multiplied the 3 numbers together. Like in 9th grade class, we can do 4 times 1 times 11, right? And I completely ignored the negatives now because like we talked about, they go away. They made a plus. What is 9 plus 44? Good. So this transitions us now to the next step in the process. And this is where we have three things that can happen. And I've structured this lesson very much on purpose so that we keep getting samplers of different things that can happen. You're about to see scenario number one. So we're going to say x equals -3 plus or minus the square root of 53 all over 2. So far, so good. Now, at this juncture, that's the part of the lesson that I think I suck at. I got to get good. I got some years to figure this out. At this part in the problem, there are three things that can happen. Number one is you can get what we call a dead root. Remember dead roots? If it's a dead root, if you can look right at the square root that's in this problem and say it's dead, the problem is over, done. Put a box around it, move on. Another thing that can happen is you look at the root and it can be broken down. You remember how we did the little trees? And if it said like the square root of 24, we'd make it into like root 4 and root 6. That's another possible scenario. And Gage, that's where the Dorito comes into play. And then there's a third thing that can happen, and that is that the square root can actually just be a perfect square rootable number, like 25 or 100. That can happen too. So as we go through these next problems today, you're going to see I'm trying to jump us around from scenario 1, 2, 3, 2, 3, 1. Like I'm trying to get us a sampler. What can you tell me about the square root of 53? Can you break it down? Then this is the final answer. Put a box around it, send it. If you really watched the video, you saw me go off to the side and show people what these answers mean. A lot of times kids think that this answer doesn't make sense. And by that, I mean like all the time. Like, what is this? What is this? Like we're used to answers like x equals 4 and x equals -8. Like, what is that? And so the point of that, when you watched the screen turn white and I went on to Desmos, what I was trying to show my students is that these are not answers that don't mean anything. One of the answers, and I'm only going to explain this to you, do it as few times as I can. One of the answers, if I watch this, I'm going to circle the plus sign with a yellow. One of the answers in this box says -3 plus the square root of 53 divided by 2. That's an answer. Just like on your quiz yesterday, x equals 4. That's an answer. It's a weird answer, but it's an answer. And then the other answer is if I take this other pathway, the minus, the other answer is -3 minus the square root of 53 divided by 2. So if math people had you write out answers like this separated, then your answers would be x equals yellow guy, comma, x equals red guy. But when we use the formula, we tend to just glob them into one, shortcutting with the plus or minus sign. Would you like to see what those look like on a graph? It's up to you. It has no bearing on your success or lack thereof. I just thought you might. Maybe we'll save that for tomorrow sometime. So for now, know that what's in the white box is the final answer. Done. Box it, full send. Good? You want to sing the song? Oh, it goes like this. It goes, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. It's like the dun, da, da, you know, the Jack in the Box. Da, dun, da, 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 da. Who wants to sing it with me? Landon, you got this? The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. Shyla, you want to sing it with me? Jess? You got you're not on your phone, are you, Jess? Oh, okay. I see that lunch pail. I get a little. Whew, thank goodness. Anyone else want to sing it? Hey, listen, I'm recording on YouTube and I sing it, you little chickens. Come on. Dallin, you got this? Root? Gage, you want to go with me? We'll do a duet. All right, maybe, okay, let's do another problem and then maybe a little chickens will get over your. I don't know yet. Yes, I do. This is our second example. Eventually, time permitting, we'll get to problems where I'm going to start having you move some things around. Like that should happen here in a little bit. But my primary concern at this point, like I did on the last quiz, you remember how I bailed out and didn't make you move terms around? I just forced it all equal to 0. That's really the primary objective here. So here we go. It's all ready to go. Set equal to 0. The quadratic formula does not work if your quadratic is in pieces all over the place. So you got to have that standard form equal to 0. And we're ready to go. What's A? What's B? What is C? Nice job. So that's key. Identifying those numbers, and now we're off. And I'm not going to keep writing down the purple formula. You have it. You know it. Here we go. X equals what? The opposite of 6 is -6. Well done. Plus or minus a big, long square root sign. First thing that goes in the square root sign, which is 36. Then -4 blank blank. Come back to it later. You may find that my little come back to it later thing is dumb and you don't do it. That's fine. I just like to come back. And then I divide by what? 6. Good job. 2 times 3 is 6. Remember, the bottom is always going to be 2 times A, the first number. Now I'm going to go backfill. What goes in place of the first parentheses? Second parentheses? Is this a switcher or a keeper? It's a switcher. And every time I ask you that, in case you're like, oh, what are you talking about, dude? I'm talking about this sign right here. The key really is, does that stay as a minus or does it switch to a plus? And again, about 50% of the time, it's going to switch to a plus. So inside the square root, we're really just going to do some mashup work. The key here for you guys, and I'm going to keep drawing this until basically you tell me to stop. This green cloud is the key. You must identify it and separate it from the other. The 36 is like, whoa, you wait your turn, homie. We're going to multiply the green cloud. So first off, is the answer going to be positive or negative? It's going to be positive because there's a -4 at the beginning and a -2 at the end. They're going to come together and make a plus, a positive, right? So what is 4 times 3? Stop at the negatives, and that's going to kill us. If we first have to talk about the signs, and then let's never speak of it again. Once we say that it's going to be a positive, to heck with the negatives. Clear? We already know they're going away. Ignore them. I ask you again, what is 4 times 3? What is 12 times 2? 24. Again, notice no mention of negatives in there because they're already gone and we know it. So really what's happening inside the square root sign is no longer what you see. It's 36 plus 24. That's the killer step there. It shouldn't be, but it is, that all that negative stuff. You just figure out if it's negative or positive and then move on. Ignore the negatives once you know what they're going to do. What is 36 plus 24? Nice. So right now we're looking at x equals -6 plus or minus the square root of 60 all over 6. And I present to you now scenario number 2. Scenario number 1, what you had inside your square root was a 53, a dead root. We boxed it and said, those come to be your favorite, obviously, because there's less work to do. These become probably your second favorite, maybe your least favorite. I don't know. But what's the deal with the square root of 60? You can tree it down, break it down, simplify it, right? So what I do over at this point is I head off to the side and I do what my teacher taught me. I make a square root of 60 and then I build a tree. And before I even get started, I build my 2 blank square root signs. What 2 numbers multiply to make 60 that I care about? Not interested in 6 and 10, right? Not interested in 2 times 30. I'm not interested in 3 times 20. I'm not interested in any of those. That's the one I'm interested in, 4 and 15. So 4 times 15 makes 60. And what is the square root of 4? Good. So we get 2 root 15. So the way this happens now is, and I'm going to do it the way you would do it on your paper. Like I can grab things digitally and move them around. You can't really do that with a pencil. So what you do next is you write the answer over again, except you take where it used to say the square root of 60 and you sub in 2 root 15. Still equals the same thing. It's just more mathematically proper. And if you really, again, I can tell Gage did, the rest of you, if you really, really watch through and listen to that video, you know this is where the triangle comes into play. Somehow, some way, in some lesson, it became known as a triangle or a Dorito of awesomeness or something. I've called it so many things over the years. I sometimes what comes out of my mouth, I feel like I'm not even in control of it. So one year it was like this Bermuda Triangle, and then it was the Dorito of doom and the Dorito of death, and the I don't even know. The bottom line though is at this point, now that we're in like scenario two, that's where this green guacamole colored Dorito is going to come into play. So what we're all going to do, and you don't have to do this forever, but I think initially what I found is it really helps is draw a triangle around just those three numbers. Notice please that the square root does not get to go in the Dorito of awesomeness. He gets left out. Poor guy. What I'm looking for is inside that Dorito, can every number in the Dorito be divided by the same amount? It's like reducing a fraction on steroids. Can they all? But what can they all be divided by? So this is a math thing. This is part of what we call simplifying. So what I'm going to do is I'm going to take all three numbers in the Dorito, this one, and this one, and I'm going to divide them all by 2. And when I do that, I will have arrived at my destination. So what is the first, the -6 become? -3. What does the 2 become? 1. And I don't need this particular one because he's multiplied by something. And as we know, 1 times stuff, bless you, the 1 is not something we need. So I'm just going to put root 15. Heck with that 1. And then I'm going to put it all over, put a box around it, send it, done. If you're tempted to cancel or reduce those 3's, get over it. That's that picture you keep seeing on my desktop about cancel kitty. Remember, have you guys seen this picture? Have you looked at it? You can't do that. It's not allowed. Kittens die. Like terrible things in the world happen. The planetary orbits get like out of line when we try to reduce things illegally. So despite what you will feel as a temptation, do not think that those 3's are in play. They are not. Only if they're all in the Dorito can we play. Got it? All right. You might probably already know where we're headed with this, but here comes example 3. This one's a bit of a whopper. I apologize, but the way I had to structure these problems, we got some pretty big numbers on this one. So I hope you got your calculators at the ready. Oh yeah, 100%. And there's no way we're getting through 12 of these today. I'll be happy if we get through 6. You learning the quadratic formula? Yeah. Then it's a good day. Other than the fact that the Avalanche got trounced by the Dallas Stars last night, we're still going to make it a good day, right? They live to fight again tomorrow night. What was the score? 4-1. Maybe they wound up 4-1. It was terrible. They played so bad last night. Yeah. A is 16, right? B is 16. C is 3. Yeah. So it's good to have your calculator unsheathed and ready. It can't do it all for us. We wouldn't want it to, but it can help us with some of the heavy lifting, some of the bigger like calculations we have to do. So let's begin. X equals what goes first? -16 plus or minus a big long square root sign. What goes first inside the square root? B squared, which is what? Certainly not 32. 256. That was a slow motion dumpster fire. Pull over and watch that one. B squared is 16 squared. So that's what the calculator's for. A lot of you probably don't have that memorized yet. That's all good. And then we're going to put minus and 4, and then we're going to put a blank and a blank, and then we're going to go to the bottom, and on the bottom we're going to double A. What's 2 times A? 2 times 16 is 32. So, there's different things we got to do, like square this, double this, just be on your game. Now let's go backfill A and C. What goes in place of A? What goes in place of C? Is that minus going to stay a minus or switch? Good job. It's going to stay. So in a case like this, when I do my green cloud, I think of it a little differently, and this is just how I make my math life a little easier, is I kind of leave the minus out because he's not going to change. And now I just got to do some basic math. Inside that green cloud, what is 4 times 16? And what is 64 times 3? 64 times 3, 192. So the math problem that's actually happening inside the square root is 256 minus 192. You should write that down. Like just seeing it will help us to not do stupid things, I think. Now we got to do a little math here. What is 256 minus 192? It is 64. And I present to you scenario number 3. And what is significant about this scenario? Yes. So as I said 20 minutes ago, there are 3 things that can happen with the square root. Technically 4, but the 4th one probably isn't going to make it into the lesson today. The root can be already dead. Woohoo, easy. The root can be workable, like the last one, or the root can just be killable, rootable, like this. And this is what scenario 3 looks like. These will be your least favorite, I'm guessing. A few days from now, when we're like really good at this, you'll find these and go, yeah, we call these pathway problems. So I'll show you why I call them pathway problems here in a second. So job 1 is to look at the root and make some damage on it. What is the square root of 64? Straight up, not root 8, no root left over. So when I rewrite this answer now, it's going to look like this. X equals negative 16 plus or minus 8. Do not put a root there. The root went poof, gone. And that's what makes these problems so uniquely annoying, is that now I've got to do quite a bit more math than I had to do in the other problems. And so this is where I gave it the name pathway, because I view, do you guys ever read like a choose your own adventure book? Is that still a thing? I always use that as my analogy, because I feel like in a choose your own adventure book, like you get to this thing where there's like a dragon and so you fight the dragon or run like a wussy, right? So like here, there's 2 pathways that we have to choose. And basically you track one pathway and then you come back to page 54 and you choose the other pathway. So the pathway that I'm referring to first is called plus. And you must trace this pathway with me. We have to walk down this trail. What is on the top negative 16 plus 8? So one of my answers is negative 8 over 32, which I will reduce. It's just a fraction after all. What does that become? So one of your answers is negative 1/4. We took a pathway and it led us to an actual normal answer, right? You with me there, Landon? You okay, buddy?
Yeah.
You zoned out, weren't you?
Yes, I was.
Now, the other pathway I'm going to color in yellow, and that's called minus. And so follow the yellow pathway with me. What's negative 16 minus 8?
24.
Negative 24. And then we put it over 32, right? We're creating these red and yellow answers by taking the pathways. And good God, son. And what is negative 24 30-seconds if we reduce it down? I think you can divide them both by 8, right? What does it become? So your 2 answers are over here. Now, before we take a break, I would explain this. And you might say, well, no one has ever said this. But someday a kid's going to say, why does that happen? Here's why it happens. The beginning problem. Do you remember the beginning? It's about 5 minutes ago. It could have been factored. You're welcome to check my handiwork. You should probably want to, because you probably think I'm making this up, huh? But look at those 2. I could have put this on yesterday's quiz and you could have solved it. How's my math? Do you want to check it? 16x squared, right? Perfect. Plus 12x plus 4x makes plus 16x. And then finally, 1 times 3. Hot dog. The moral of the story is this. If you get, when using the quadratic formula, if you get quote unquote normal answers, it always means that the problem originally could have been factored. Usually we don't know that until it's too late. All right, what do you, about 30 seconds or a minute, and then we'll come back to this? Yeah, what's you got a question before I pause this? What's up? Um, yeah, the point I'm trying to make is that like we wouldn't know really like out in the wild going into it if it was factorable or not. So the quadratic formula, it's kind of like by the time we get into the quadratic formula, we hit a certain point where we realize now it's probably going to be quicker just to finish the formula than it would be to go back and try to figure out the factors. Like if this were on yesterday's quiz, then of course you would try to factor it, right? That's what you would do. But with the quadratic formula, by the time you're a minute and a half into it, it's really just quicker to say, oh, and then you finish it that way. Does that make sense? Okay. If you happen to find while working with quadratics that one is factorable, yeah, get down with your bad self. But the formulas really are going to be our more consistent method. All right, I'll pause this real quick. You can have a minute or so, and then we'll come back. Fresh page for me. I don't know about you. All right, here we go again. Round 4. What changed? Right, there's no zero. So as with what we talked about like a week ago, the zero is not really up for negotiation. So we are going to power all of our stuff to the left because that's where x squared is. So we're going to bring 11 over, and our actual math problem is not on the board yet, but now it's about to be x squared minus 2x minus 11 equals 0. Remember to switch it. So, all right, let's begin. What's A? B? No. -2. C? Nice. So those are our guys. That's our cast of characters. Let's plug them in. Let's begin. Anyone ready to sing the song with me yet? All right, whatever. Well, when you change your mind, let me know. I'll sing with you. I'm not scared. Chickens. All right, let's begin. X equals what goes first? Is not -2. It is +2. And wanted to make sure we get one of these in the notes today because again, I don't want you going through the next few days thinking that, oh, it's always a negative number there. Nonsense. If the B is already a negative and we negativize a negative, then it goes back to being a positive, right? So what goes there will not be a negative. It will not be a positive. It will be whatever it needs to be the opposite of B. And then we're going to put plus or minus a big, long, awkwardly long square root sign. And what is the first thing that goes inside the square root sign? What is -2 times -2? +4. Do you think the number with this big yellow arrow pointing at it will always be positive? I agree. No matter what your calculator tells you. I've had people who like, let's say B is like -18, and some knucklehead types in -18 squared and then puts -324 there. And I'm like, man, you are crazy. That that is not how you type squaring into your calculator, right? This knucklehead forgot the parentheses. So knowing that that B squared is always going to be positive, if it's a negative and use your calculator, just don't put the negative in, right? That's always going to be a positive number. All right, how many times I say that? Here we go. -4 blank blank all over 2. 2 times 1 is 2. What's going in the first parentheses? Second parentheses. Is this a keep minus or switch? This is a switcher, dude. So again, as far as I'm concerned, all those negatives, you're dead to me. All I got to do now is just a basic math problem, and that is 4 times 1 times 11. I think we've seen this one, 44. So what's really happening inside the square root is now 4 plus 44. And what's 4 plus 44? 40. Beautiful. So now it's my time to identify, okay, what scenario am I in? I'm looking at 2 plus or minus the square root of 48. Is this the dead root scenario, simplifiable, or just rootable? Simplifiable. 48, you might remember a long time ago, was on our death list, right? Does anyone by chance remember the breakdown for the square root of 48? He's a bugger. Someone might be saying it, I just can't hear. It has nothing to do with the number 8. I heard it whispered. There it is, 16 and 3. That's why it makes the death list. We just don't think of 16s, but it's there. What's the square root of 16? 4. So we have 4 root 3. So I'm going to take out the square root of 48, and in its stead, I'm going to put 4 root 3. And now it's time to draw the Dorito, because if you break someone out of jail, the Dorito is going to come into play. And the Dorito will usually have a purpose. Like there's usually work to do. There will be instances in which you look at the Dorito. It's honestly, I don't know. It doesn't happen like hardly at all. But usually the Dorito is going to be productive. So when I look at the numbers inside that guacamole colored Dorito, I see that they can all again be divided by 2. Now you'll remember that in the one, I think it was the second example we did today, that we got a 1 that we didn't put. One of the ones we're going to get we'll need, and one of them we can omit. So let's begin. We take all these numbers, kaboom, 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 and we divide them all by 2. What does the first number become? You need that 1. It is a placeholder. That place has to exist. Remember that. And then we're going to go plus or minus. What does the second number become? 2. And what does the bottom number become? You do not need that 1. So what we find is that when things cancel and make 1s, we actually only need to put the 1s when they're in the place I'm putting a purple box around. If the 1 winds up going there, then you keep that. If a 1 shows up in either of the other 2 Dorito spots, take it out. 4 down. How you feeling? Good? You got this? Yeah. Right, let's go again. 5. We got 5x squared plus 3 equals 11x. What do we do first? You get that 11x over where he belongs. So 5x squared is like, I'll just kick it here. What goes next? Minus 11x. Remember, you got to move that guy, and it tucks right in its home in between the other 2 terms. Plus 3. And that equation is now solved. I mean, situated and ready to go. What's A? 4. 5. Did you say 4? Because you made me write. Oh, I thought you said 4. Like you actually Jedi mind powered my pen into writing. What's B? What's C? And it's time to roll. We got our numbers. I can scroll all this off the screen now because really that's all I need. Here we go. X equals. What goes first? Job. Plus or minus, big, long square root sign. What goes first inside the square root? It's exactly 121. Never put a negative number in that spot. Never, never, never. And then go minus 4 blank blank all over. What's 2 times A? Beautiful. Right, let's see what happens. In the first parentheses goes 5. You said 4 that time. No. I heard. Yes, you did. How do you pronounce your 5s? 4. It's not 4. No. 4. Doing. 4. Second parentheses. 3. Is this going to stay as a minus or switch to a plus? This will stay as a minus, right? That's honestly one of the biggest hurdles as a teacher is, can I get these kids to know, is it a plus or a minus? And I mean, it's either going to stay a minus or switch to a plus. That's it. So I'm going to do the mathematics in this little green cloud right here. And we can do this. We don't need a calculator. What's 4 times 5? What's 20 times 3? So what's really happening inside is 121 minus 60. And what is the answer to 121 minus 60? It is indeed. And that, my friends, is great news. If you haven't come to appreciate that, you will. But why is that great news? It's a dead root. And those are our favorites. We're not lazy, but given the option, I'd rather have the problem end now. So Box it up, send it. Square root of 61 is dead. There is never a chance for a Dorito. No. One more. I hope one more, maybe two more. Aren't we having fun?
Yeah.
See if I have time to quick pour myself a little shot of coffee here. What do we do? Yep, we're moving all of our stuff to the left in this case because that's where x squared is going to be present, right? So I'm going to add the 3x squared across. How many x squareds will I get? How many x's do I have? Just minus 8, right? He never has anyone to go with. What will my constant term be? Nice job. -1. Add 4. So I say every time, you don't want to hinder your progress by messing up basic math. So pay attention when you're moving things over the equals. What's A? 5. What's B? What is C? And we begin. X equals what? 8. Y'all getting that? How that first number is going to be the opposite of whatever B is, right? Sometimes positive, sometimes negative. Then we put plus or minus, then we draw a big, long square root sign. Leave yourself plenty of room. What goes first inside the root? 64. Beautiful. -4, blank, blank. All divided by 10 again. What goes in the first blank? Second blank. -1. So I present to you, as I do every time at this stage in the process, is it going to stay subtraction or switch to addition? It is going to switch. So at this point, we no longer discuss the negatives. We just look at the numbers. So at the back end, I got a 4 times a 5 times a 1. What's 4 times 5 times 1? 20. So really what it says inside the square root is 64 plus 20. Keep it simple, stupid, right? Like don't get all hung up on negatives. It either switches to plus or it doesn't. Just look at the numbers. What's 64 plus 20? All right, so this is not, we're not as fortunate this time to be able to just box it up and send it because the square root of 84 is not dead. So now I need your assistance with, I'm going to head off, switch to yellow, go off to the side, and my job is to break this down. '84 has a lot of factors, but there's one that I care about. No, 32 doesn't go into 84. It would be the score that you got on a golf hole if it were a par 3 and you got a bogey. I see we're not golfers here, okay? So that would be a 4. So it just so happens that you guys not play golf? What's wrong with you? Every hole has a par, like the score you're supposed to get if you're a perfect like scratch golfer, right? So if it's a par 3 and you get 3, you get a par. If you get a 2, you get a birdie. If you get 1 over that, that's a bogey.
Double bogey.
So this is 4 times 21. That's the best we're going to do with 84. It's 4 times 21. You guys still talking about golf?
I love golf. I can get
So what am I going to replace the square root of 84 with? And the Dorito is officially in play. So, and I say drawing the Dorito is so not something you have to do. It's just something I decided to start doing years ago. Well, some college professor is not going to go, I noticed you don't draw the Dorito. Like, they don't even know what the heck you're talking about if you say that. They're going to think you're high. They're going to send you for a drug test talking about Doritos. What can all the numbers in the Dorito of Doom be divided by? So we are going to have a 1, and this is going to be a 1 that I don't need because it's not in the essential spot. So what's my final answer? 4
Plus
over. There was one more example in here that I wanted you to see. Here it is. I can do this. We have to go fast, okay? Because I got only like 3 minutes. So here it goes. And I'm not going to make us move stuff around. I'm just going to get right to it. X squared plus 10x plus 25. Oh, yay. I'm so glad I got to this one. Found it. We're going to make it. So what's A? B? C. Dope. Let's go. All right. So X equals what first? Plus or minus big long square root. What goes first inside the square root? 100. And then I always just put minus 4 blank blank. I don't even think about it. I just like autopilot on the pen. All over what? What's going in the first blank? What goes in the second blank? Now, the scenario is a little bit interesting, and it causes people to say things like, Mr. Ahern, what did I do wrong? And the answer is nothing. So here it goes. This is wacky. Don't pack up now. What a terrible time to think this is over. Inside the square root, it's going to stay as a minus, of course, right? And what is 4 times 1 times 25? And so the math problem is actually 100 minus 100. And what is 100 minus 100? And what is the square root of 0? And what is the purpose of adding or subtracting 0? There isn't one, which leads us, my friends, to the fourth scenario, which is this. X equals negative 10 over 2. You might say, I thought you said quadratics always have 2 answers. They do. This one has 2 answers. They just happen to both be the same. So the answer to this one is X equals negative 5. Done. All right, that concludes that. I'm not even going to put the Delta Math assignment up. I'm gonna put it up in the morning before class. Okay. All right, cool.